Hi everyone. Today we'll talk about nucleophilic addition reaction of primary amine and secondary amine. First thing first, let's make sure we understand what a primary amine is and a secondary amine are. So a primary amine is an amine group where the nitrogen is attached to only one carbon, R being any carbon chain. So primary is nitrogen bonded to one carbon, and a secondary amine is a nitrogen bonded to two carbon. So for the nucleophilic addition reaction of primary amine and secondary amine, the result of each of them is different from usual addition reaction, because instead of taking the pi bond away or going from a double bond to adding two atom, we not only do this, we break the double bond, the initial double bond, but we reform a double bond eventually to, for a primary amine, we form an amine. Amine is a carbon pi bonded, or with a double bond bonded to a nitrogen which has anything attached to it. And for a secondary amine, it forms an enamine, which is a carbon-carbon double bond bonded to a nitrogen. So for the mechanism of a primary amine, we also need a weak acid. So let's do let's do a primary amine. All right, so in here we have a nitrogen bonded to one carbon and to two hydrogens. So we have a primary amine. This is going to be our nucleophile, this lone pair here. And we have our ketone here, double bond, a carbon group bonded to two carbon. So first thing, an amine, being a strong nucleophile, is going to attack the carbon, which is the electrophile, making this pi bond roll up at the same time, forming this intermediate. Now, in an amine nucleophilic addition reaction, we have intermolecular reaction where this anion, or this oxygen with a negative charge, is going to grab the proton, or this, because there's a positive charge here, it's going to grab this hydrogen, making this nitrogen regain its lone pair and then become neutrally charged again. So it's a good for a good. So in this case, we then obtain an OH, and we have here our nitrogen, which is neutrally charged again. Now the only thing left to do, well, one thing you have to do still is the protonation of this alcohol group to make it a good leaving group. So the lone pairs are going to attack the hydrogen, forming this water here. Start again here. So now we will, the leaving group is ready to leave, and then we will have water that leaves, and we will be left with a resonance structure we will be left with this we'll be left with this resonance structure here, plus the water that left from here. And now the only thing left for our amine product is to the only thing left to do is to deprotonate using a base to deprotonate. Oh, sorry, I forgot about that. This hydrogen to deprotonate this nitrogen here from its hydrogen, forming our final amine. So now we obtain our amine. So look at what we did here. We had the nucleophilic attack. Then we had protonation of this oxygen. Then we also had protonation of the leaving group, making it a good leaving group. Then we had leaving, the leaving group leaving, forming a resonance structure here that allowed us to deprotonate and then form our expected product, the amine. Now, the mechanism of a second amine, and you'll understand why there is a different product, thus a different stepwise mechanism for a secondary amine, different from the primary amine. So we then, let's start with an aldehyde group plus this secondary amine. Don't forget, we will be in need of the weak acid, because the weak acid is used in the primary amine in this step here to protonate the leaving group. So in here, the first step, we can see here how we have a secondary amine, and amine is a strong nucleophile. So first step is the nucleophilic attack. Lone pair rolls up, forming this product here. Same thing as earlier. This negative charge is going to attack this hydrogen. Oh, again, which is ready to leave because this nitrogen here is going to receive is lone pair and then be neutrally charged again. So everyone's happy. All right, so now it's pretty much the same thing as earlier. Now we have, again, the protonation of the leaving group. H3, H. I forget the lone pair sometimes. All right, so now this leaving group is ready to leave, giving us this resonance here. Oh, not a plus. Yeah, those are resonance. Intermediate. Now, the difference in the primary amine and a secondary amine is that in this case here, because it is a secondary amine, it only had one proton that could be deprotonated. So in this case here, so I have water. Earlier we had the primary amine that was deprotonated in this step, and that still had another H to be now deprotonated in this step, forming the amine. Now that we only have one proton to deprotonate, we are now at the step where we have to deprotonate this hydrogen here, forming a double bond. So this hydrogen is going to leave. The bond that would bind the carbon, or the hydrogen to the carbon, will then flip and form the pi bond, forming a carbon-carbon double bond. So what it's going to look like is this lone pair is going to attack this hydrogen, making its bond come right here, forming the final product, which is this amine. So, like I said, it's very important to locate whether it is a secondary amine or a primary amine, because it will differ in the amount of proton it can be deprotonated, which will then affect the final product. So I hope this helped, and if you guys have any questions, just leave them in the comment. Thank you for watching.